Alright, this video is on Q equals mc delta t, which is a formula used to find a variety of different variables. Um, Among them is Q, which is the energy, usually given in joules. Okay, now sometimes, change the color on that. Sometimes I could ask for calories or ask for kilojoules. Of course, you would have to do a conversion to get it to joules. Another one is mass, right, which is usually in grams. C, which stands for specific heat capacity, and the usual unit there is going to be joules per gram degrees Celsius, so grams times degrees Celsius for that unit there. And then change in temperature, which is going to be in degrees Celsius. Now, another way to indicate delta T is going to be the temperature, the final temperature minus the initial temperature. Now, important fact to realize is that if you have a sample that's undergoing a change in temperature, okay, you're going to use this equation to determine, the size of that sample or the heat capacity of that particular material or the energy going in to make that temperature change, okay? Well, if there's a temperature change, you're going to use this equation, all right? So, when you're doing these problems, make sure you keep in mind that these units, okay, these units right here are the ones that need to be, are the ones that you need to have converted to. So for example, if I give you a question about, in the question there's milligrams, make sure you convert the milligrams to grams. Or if I give you a problem where you're needing to solve for, say, mass, and I give you a Q value with calories, make sure you convert the calories to joules so it follows the same format of this video, okay? So let's go ahead and jump into a problem here. So a sample of water with a mass of 550.6 grams undergoes a temperature change from 16.57 degrees Celsius to 38.88 degrees Celsius. What is the heat change, okay, in joules? So one thing I definitely want to have stand out right here is we know that heat change can be a positive or a negative number, okay, just showing the direction of the energy as far as where the heat is going. So if I was to guess if the heat change was going to be a positive or a negative value for this problem, I would guess it would be a positive value because as thermal energy or as heat increases, so would temperature, right? If I heat something up, the temperature is going to increase. Well, if I look at my temperatures right there, I'm going from 16.57 to 38.88. So my temperature is going up. Chances are my heat change is going to be positive. All right, so let's go ahead and find that out. All right, so my formula, Q equals mc delta T, okay? I don't have to rearrange this equation at all to get what I'm looking for. I'm looking for Q, because that's what joules is. Joules is the unit of energy, and Q is my variable. My mass is 550.6 grams, okay? My specific heat capacity, it's not listed in the problem, but it tells me what the substance is. And water's heat capacity, or specific heat capacity, is 4.184 joules per gram degree Celsius. Now, it's important that you know that value, okay? One, it'll just make things go a lot faster. And the other is I'm not going to give it to you, so you better make sure you know it. The last little section right here is going to be my change in temperature. Well, my change in temperature is going to be 38.88 minus 38.88 degrees Celsius minus 16.57 degrees Celsius, okay, which is 22.31 degrees Celsius. Okay, that's what this is going to equal out to. Okay, so now it just comes time to do the multiplication. Right, now I am applying sig figs here, and every single one of my numbers that I'm multiplying right here is going to have 4. So when I do a full product here, I'm going to have 4. So my final number ends up being 5139.78. Again, I need 4, sorry, my units. Okay, can't forget to cancel units out. Grams cancels out, degrees Celsius cancels out. I'm left with just joules, so my final answer is in joules. But this, of course, is not my final answer because I need to have number of sig figs. Okay, now my numbers in my multiplication problem all have 4 sig figs. If I try to do 4 sig figs here, 5, 1, 4, 0, 0, right? Oops, did I get that right? What is it? Oh, 1, 5, 1, 3, 3, 9. Oh, there's a 5 right here, that's why. Okay. So this would be my number, 51,400. That, of course, only has 3 sig figs. Okay, but this is an acceptable answer because I have fewer sig figs than I started with, and the reason why I end up having fewer is because I have to include a proper rounding step. Now, I cannot add a decimal to the end of that number because then that ends up having more sig figs than I need, okay, or that I should have. But understand, if I really, really need to have the same number of sig figs as what I'm supposed to have, I can always put it in scientific notation. 1.40 times 10 to the 4th joules. Okay? And there's my final answer there. All right, take a look at another one. We have a sample of water with an unknown mass undergoes temperature change from 37.81 to 78.98 degrees Celsius with a concomitant change in heat content of 55,760. Okay, this word right here just means accompanying. So there's an accompanying change with this temperature increase, and the heat change is going to be an increase number of joules. So 55,760 joules is what's going in. I want to know what the mass is of this sample. So the mass of water. Well, Q equals mc delta T. I rearrange this equation to end up looking for mass. Mass is equal to Q divided by QC delta T. Okay? So as I'm doing this, I'm going to plug in my Q value. So I'm going to go ahead and move this down here. Okay? Q is 55760 joules. Right? And I'm going to have C, which is 4.184 joules per gram degree Celsius. Now, the reason why I know that is because it is water. Okay? And my temperature change, in this case, 78.89 minus 37.81 is going to be 41.08 to 8 degrees Celsius. Now, when I'm doing these problems, I need to do my multiplication of my denominator first, which is going to be, so 55760 joules. My degrees Celsius is going to cancel out right here, so my unit down here is going to be joules per gram. And it ends up being 171.9 because I have 4 sig figs in each of those two numbers, this number right here and this number right here. So my joules will then cancel out. I'm left with 324.37. I need to have 4 sig figs, so my 4th sig fig, number 3, is needing to look, or my 5th sig fig over here, the 7, is going to determine that I need to round up. So 324.4 grams is my final answer there. Okay, a 35.4 gram metal sample undergoes temperature change from 73.8 grams, or 8 degrees Celsius to 78.9 degrees Celsius with a concomitant change in heat content of 76 joules. What is the specific heat capacity? So again, I have a temperature change, which means I'm going to use Q equals mc delta T, which means if I was to rearrange this equation to solve for specific heat capacity, which is C, C is going to equal Q over m delta T. Right? And I'm going to go ahead and start plugging my number in. Okay, so I'm going to have 76 joules divided by the mass, which is 35.4 grams, times the change in temperature, which in this case is 5.1 degrees Celsius. Now, if you notice here, when I'm solving for specific heat capacity, right, I'm not going to have any units cancel out because I'm solving for the unit with specific heat capacity, which is, okay, if you take a look, joules per gram degree Celsius. Okay, looking at this, we have, I need to do my denominators first. Well, I have 3 sig figs here, I have 2 sig figs there. So I'm going to go 76 joules divided by 180 grams degrees Celsius. Okay, so I do my final calculation. I end up with 0.4222 and 2 and 2 and 2 and 2, 2 joules per gram degrees Celsius. But of course, I need to have only 2 sig figs. So my 0.42 joules per gram degrees Celsius is my final answer. Now, usually what happens is if I give you a problem like this where I'm having you solve for a heat capacity or specific heat capacity, it's going to be used to identify an unknown material, usually a metal, okay? And I'll give you a list of, like, say, 5 or 6 different metals. You solve for the heat capacity, and then you determine based on the heat capacity what the metal is, okay? So, for example, 0.42, and I had metal A, metal B, and metal C. Metal A's heat capacity is 0.90 joules per gram degree Celsius. B's is 0.41 joules per gram degree Celsius, and C is 0.55 joules per gram degree Celsius. Obviously, if I do this calculation and I end up with 0.42 joules per gram degree Celsius, then the likely identity of this metal is metal B. Okay? So, another way to apply this knowledge. A sample of water has a mass of 402.3 grams, loses 10,600 joules. What is the change in temperature? Okay. Now, I do want to point something out right here, is I'm losing energy, which means my change in temperature should be a decrease in temperature. So I should end up with a negative number when I calculate my change in temperature. If I gain, okay, so anyways, if I have a loss in joules, loss in energy, that means I'm going to have a decreased temperature, so my temperature change should be negative. Okay, I should have a decrease in temperature. So I do have a change in temperature, obviously, because I'm solving for it. But Q equals mc delta T. If I rearrange delta T, it equals Q over mc. Okay, well, my Q is 10,600 joules. Now, here's the thing. It says it loses that many joules, so it's a negative number on top. Okay? And then we have the mass, which is 402.3 grams of water. And I have the heat capacity, which is 4.184 joules per gram degree Celsius. Okay? So I do my denominator first, where my grams are going to cancel out. I'm going to end up with negative 10600 joules divided by, with 4 sig figs, 1683 joule degrees Celsius. My joules will cancel out when I do the math. I should end up only with 3 sig figs here because, remember, these 2 zeros right here are trailing zeros without a decimal, which means they're not significant. So my final answer is going to end up being a negative 6.298. But again, like I said, we need 3 sig figs, so it should be negative 6.30 degrees Celsius. Okay? Remember, decrease in joules means a decrease in temperature, and increase in joules means an increase in temperature. Okay? A sample of water with a mass of 677.8 grams and an initial temperature of 45.38 loses 18,490 joules. What is the final temperature? Now, remember, when we're doing temperature, change in temperature is equal to temperature final minus temperature initial. Okay, this is going to be important for the end of this portion of the lab, or the portion of the problem. Okay, so I know I have a change in temperature, so it's going to be Q equals mc delta T, which of course this is going to be rearranged to delta T is equal to Q over mc. And like I said, I wrote over there that delta T is equal to TF minus TI. Well, if this is equal to delta T, and this is equal to delta T, that means TF is minus TI equals Q over MC. And of course, I'm trying not to solve for the change of temperature, but just the final temperature. So if I wanted to get the final temperature, I'd do some algebra here, right? So my final answer for my final equation is TF equals QMC plus TI. Okay? So let's go ahead and clear this board so we can actually have some room to do the problem. Okay? All right, so I'll clear the board except for the equation at hand. So what I'm going to do is it's in two steps. One, I'm going to solve this, and then I'm going to add the TI, which is given. Okay, so Q, which is a loss of 18,490, so it should be negative 18,490 joules, right? Divided by the mass, which is 677.8 grams, times the specific heat capacity, 4.184 joules per gram degree Celsius. Joules per gram degree Celsius. Okay? So when I solve that out, negative 18,490 is still the same on top. And then when I do this, I should have 4 sig figs in my answer, which is going to be 2,836. My grams cancel out. Joule degree Celsius. My joules are going to cancel out here. My final answer ends up being a change of temperature of a negative 6.520. Okay, and what I need to do is, so this right here is the change in temperature. Okay, so this is value right here. This is equal to Q over MC, but I need to add the initial temperature, which is 45.38. So I'm going to plus 45.38. Okay. This number right here has 3 numbers to the right of the decimal. This one right here only has 2 numbers to the right of the decimal, which means I only have 2 numbers to the right of the decimal in my final answer, which is 38.86 degrees Celsius. Okay. Now, little check, does this make sense? Well, if my temperature ends up going down because I'm losing energy, and my initial temperature was 45, my final temperature should be lower. Well, 38.86 is lower than 45.38, so logically that works. Okay. Last one. A sample of water with a mass of 935.0 grams and an unknown temperature gains, okay, 27,070 joules. If the initial temperature was found to be 51.80 grams, what was the initial temperature? Okay, so I know I have a temperature change. Okay, and my final temperature was 51.80. Okay, so I'm going to use the same process. Q equals MC delta T. This ends up being delta T is equal to Q over MC, which is the same thing as saying TF minus TI equals Q over MC. And of course, I can rearrange this equation, okay, by doing some algebra. So what I'm going to do is go plus TI plus TI. Now this is going to look very similar to what problem I just did, right? So it's going to be TF equals QMC plus TI. Well, I need to get TI by itself, so I'm going to subtract Q over MC from both sides. Q over MC from both sides. So my final variable, which is this right here, TI is going to equal TF minus Q over MC. Okay, I'm going to go ahead and leave this little equation right there on the bottom, and we'll use it as a reference throughout the problem. Okay, so let's go ahead and, again, same way, I'm going to, well, actually it's going to be a little backwards. I'm going to do this part first, and then I'm going to do this part. Okay, so Q over MC is going to equal, let's see here, it's a gaining of joules, so it'll be 27,070 joules, positive number. Okay. Now think about this. If it's a positive number, it means I'm gaining joules. If the final temperature was 50 51.80, that means the initial temperature should have been less than 51.80 because once it gained the energy, it got up to 51.8. Okay? The mass is 935.0 grams times 4.184 joules per gram degrees Celsius. Okay? In this case, my grams are going to cancel out yet again. When I write my little intermediate step, I'm going to end up with 27,070 joules all over 3912, 4 sig figs, right? And this is joule degrees Celsius. My joules will now cancel out, and my final answer ends up being with 4 sig figs, 6.920 degrees Celsius. Okay, so this right here is QMC, right? Well, according to this equation right here, TF minus Q Q over MC is going to equal my initial temperature. So my final temperature was 51.80 degrees Celsius, and I'm going to subtract 6.920 degrees Celsius. Okay, so remember our sig fig rules when adding and subtracting. I have 2 numbers on the right of the decimal here. I have 3 numbers on the right of the decimal there, which means my final answer needs to have 2. Okay? So, when I do this subtraction, I end up with 44.88 degrees Celsius. Again, does this make sense? If it started at 44.88 and I gained energy, that means my temperature must have went up, and it went up to 51.8. Okay? So, this video was fairly long, a lot of stuff in it. Watch it as many times as you need to. If you have any questions about what I did at a certain point or where I got a number, then make sure you ask.